Right, so in the last video we reflected a triangle around the line x equals -1. Now we're going to look at what happens when we reflect a triangle around the coordinates, around the line y equals x. Well, if we look here at the very first point, 1, 1, we can see that that's actually on the mirror. So the reflected triangle will be in exactly the same point on the mirror. It won't move at all. The coordinate 3, 1, we want to be able to draw a right angular angle between the coordinate 3, 1 and the mirror. And we hit the mirror at exactly a triangle. It didn't, sorry, this pen isn't very responsive. It's difficult to get my lines perfect here, but let's try again. We want to draw a line from the coordinate 3, 1 at a right angle to the mirror, and then measure the distance here that we have gone to get from 3 to 1. Well, the coordinate that we're ending up at here is about 2, 2. We need to go exactly the same distance from this right angle, and my pen is not very responsive again here. Let's see if we can get it a bit more accurate. We want to go exactly the same distance on the other side of the triangle as we started off at. So this will give us our second reflected point on the triangle. So where we previously had 3, 1, we go through and we're going, until we get to the mirror, we're going 1 across, -1 in the x direction and up 1 in the y direction. We're doing the same thing here on the other side of the mirror. So here we can see we're going approximately -1 here and up 1 there. So we're going up 1 here and -1 here, giving us our new coordinate. You can see that we're going the same direction in the x and the y. And the coordinate that we're getting our new point on the triangle is actually working out at 1, 3. 1 across in the x direction and 3 up in the y direction. What about the point 4, 3 then? Well, we make again a perpendicular angle from the coordinate we're going into the mirror, and then we move the same distance. The reflection of the mirror is the same distance on the back side of the mirror. And instead of being at 4, 3, we can see that we've gone from point 4 to 3 to get to the mirror. We've gone along and up that amount, a half, and along and up a half there. So the coordinate we've ended up with on the other side of the mirror is 3, 4. So our new triangle ends up looking as a mirror image of the blue triangle. I'm writing it here in red. Try and get rid of some of these help lines that I put there so that you can see the triangle more clearly. And we can see that the triangle is a perfect reflected mirror image, and look what happens with the coordinates. 1, 1, when inverted, we change the place of the x and y, stays as 1, 1. Whereas the 3, 1 that we had down here, reflected through the mirror of y equals x, actually inverts. The 3 and the 1 have sort of changed places to give us the coordinate 1, 3 in the reflected coordinate of the triangle, in the reflected triangle. And again, 4, 3, which was the coordinate of the original triangle, once reflected around y equals x, gives us the coordinates 3, 4 on the other side of the triangle. So reflecting triangles through the coordinate y equals x is really easy to do, because we just can take the coordinates, flip the x and the y around, and it gives us the coordinates of our reflected triangle. So we don't actually have to measure and draw these perpendicular lines from every coordinate backwards into the mirror at the same angle as we started at. We can actually just drop in the coordinates directly by flipping them around, the x and y, writing the coordinates on the graph, and getting our graph perfectly correct without any mistakes for measuring or not getting the exact right 90-degree angle. So this is a very useful technique whenever you are reflecting an image around the coordinates y equals x. You just flip the x and y coordinates over, so 4, 3 turns into 3, 4. 1, 1 stays the same because flipping x and y over would still give you 1, 1. And 3, 1 turns into 1, 3 in the reflected image. Okay, good luck.